Afternoon, guys. My name is Sapoloitu Makoma. I'd like to first just to thank you guys for your support, for supporting my channel and also for supporting what I'm doing. So this is our first session online. Yeah? As I've said on WhatsApp that we will start our online lessons on AC machines. We'll start on AC machines. The first topic will start on AC machines. This is chapter 5 on your textbook. Chapter 5. Okay. So before we start talking about or start doing the calculation on this topic, what is first important? It says AC machine. Okay, so when we're talking about an AC machine, it's either we're talking about an AC generator, which is generating electricity, or we are talking about an AC motor, okay, which is, there are two types of AC machines. There's synchronous, then there is asynchronous, or another way to say asynchronous induction type of machine. Okay, but before I will start doing the AC machine part, I want us to first analyze or understand how we answer question that deals with AC. AC most means alternating current. There are two types of alternating current electricity. There is a single phase, then there is three phase. Let me write it down here. We have single phase, okay, then we have three phase. Okay, whenever we are dealing with AC, we must look at the question first. What is the question saying? Is it talking about a single phase system, or is it talking about a three-phase system? Okay, which is not a problem if the question is talking about a single phase system. We don't have to worry now. We use those given values when we are calculating, because with a single phase we don't have a line voltage or a line current, so we don't have to convert. Okay, we don't have to convert in single phase because there is no line current or line voltage. All the values in single phase system are phase values. For example, all the values here in the system is phase voltage and line, it's phase voltage and phase current. We don't have a line value on single phase. Okay, the reason I'm starting with this part is because, guys, whenever we are doing calculations on AC, the only values that we use to do calculations on are phase value and also it given values. Let me write that in red. It given values when you're talking about AC is always line values, whether when they give you a voltage and they don't say that is a phase or a line voltage, you will always take it as a line value, given that if the question is talking about three phase. So in single phase there is no line value, so we don't have a worry about that, because we know in single phase if we are given a value, that is automatically a phase current or a phase voltage. But with three phase, if you are given a voltage, the given voltage, you always take it as a line voltage. You always take it as a line voltage. For example, if the question says a three-phase star connected alternator, then they give a voltage of 320. That voltage, you take it as a line value. It is given, and when they are talking about what? A three-phase system. So you must be cautious when you're dealing with the question that is talking about a three-phase. Okay, so this brings us to this part of a three-phase system. There are two types of connections in a three-phase system. We have a star, then we have a delta. Okay, as I've said, when you are doing calculation in any AC calculation, whether it's a transformer, as long as it is talking about AC type of electricity, and they say three-phase, in a star connected three-phase system, the line current and the phase current are the same. Think of a star connected system as a series circuit. Okay, and the line voltage is equals to the phase voltage times square root of 3. So if the question is giving you a voltage of 320 and it's talking of a star connected three-phase, if it talks about the three-phase and we are given a value, we know that this 320 will take it as a line voltage. But when we are performing calculation, we must convert this 320 volts, which is the line voltage, and convert it into the phase value. We don't do any calculation using a line value. We don't do that. Let us look at with the delta. Here, think of the delta as a parallel circuit. With a delta connected system, guys, the line voltage and the phase voltage are the same. So if the question is talking about a three-phase delta connected motor or delta connected alternator, and they say 320, that is a line voltage, fine, but because it is a delta connected, I don't have to convert, because in delta the phase and the line are the same. The phase and the line are the same. So that is what you must be cautious of when you are dealing with AC. Okay, then the line current is equals to the phase current times square root of 3. So as I've said, guys, when we are doing calculations, you'll see when I'm doing the examples, we will always convert from line to phase values. We'll always convert from line to phase values before we perform the calculation when we are dealing with three-phase. When you are dealing with a three-phase, the question will tell you this machine is either connected in star or it is connected in delta. Depending if it is connected in star and you have a given voltage, that given voltage will say we always take the given voltage as a line voltage. If it is connected to in star, then we have to convert this value to a phase value before we start doing any calculation. But if it is a delta, we don't have to convert because the line and the phase voltage are what? Are the same. The line and the phase voltage are the same. So guys, that is how we tackle AC, anything that has to do with what? AC. And in most cases we will be dealing with 3-phase circuits, okay, because in a 3-phase is more common in industry than single phase. But when we are dealing with AC, with single phase, we don't have to convert because there's only one value in single phase, that is phase values only. Okay, that is where we start, guys, with the, whenever we are doing in calculation. Read the question carefully. It says, if it says 3-phase, look at it, it's gonna tell you the type of connection, then it is going to give you the values, and given values are always taken as line value unless the question specifies that alternator with an EMF, I'm making an example, with an EMF of a phase, with a phase voltage, that is telling you this, we must take it as a phase value. But in most cases they'll just give you a voltage. You should know that it is what? A line value. It is like saying in science, at rest. At rest, you know it is 0. The velocity is what? It is 0. The object, it is stationary. Same goes here. When you are given a voltage and they don't say anything, that is a line voltage. So depending on what type of the connection the question is talking about, if it is talking about star, we have to convert this voltage to a phase value. But if it was connected in delta, then there's no need to convert because a line and a phase in delta are the same.